Okay, we're back. And so what we've done, we're about to start on the three-phase full wave 6-pulse rectifier. And now we've made a couple of changes to our voltage. We still have 240 volts up there, 240 volts three-phase, and we still have a parallel connection on the top. The only thing I've changed is on the bottom where I have 120 volts of phase voltage. I've now connected that in delta down to the lines down behind me in delta. So you can think about that for a moment. So the bottom of the phases, I've gone A to B, B to C, C to A. You'll see that I don't have anything connected into the neutral bar anymore. So it's just a 3-wire secondary circuit. And I'm going to hook this 6-pulse rectifier up. It's going to be hooked up directly from line to line. And you'll recall the drawing that I showed you for the full wave rectifier. Just A, B, and C line into 3 diodes, connect the other end, and then it comes out of those into the load, from the load back into 3 more diodes, and then back to the lines. And so completely a line-to-line situation for these diodes. Now, I'm going to go ahead and I'm going to walk you through a little bit just so you can see the connections, all right? So what I've done is these 3 lines right here, these are A, B, and C coming into the top of these 3 diodes. Now, these are actually the cathodes of these diodes. Now, we go through, the anodes are all tied together, and from there, I go out through my ammeter to the load, still 60 ohms. And then from the load, I come back on this line right here. And you'll notice that this line leaves the anodes of the diodes. And this line comes back to the cathodes. And now the anodes go back to A, B, and C line. So you can see how we move in the one direction through this set, come back from the load, and actually move the opposite direction through these ones. So let's talk about voltages. In a 6-pulse rectifier, we're connecting across line voltage. And so seeing as I connected this in delta to a phase voltage of about 120 volts, that is actually what we're going to see. Now, I'm going to go ahead and turn this on, and you should see a little bit of action on the meters when I do this. Let me show them so that if they don't have any glare on them, hopefully. That's good. A little bit this way. There. Okay, when I turn this now, interestingly enough, there's a little bit of voltage. You can see it ticking away on that 1 meter. That's just a capacitive charge that exists from the actual bench. So as soon as I turn this on, you're going to see that jump, and you should see some current. Now, you'll see that we have, and let's start with this one. I'm going to bring it up close for you. 125.6 volts. Try to find a nice spot for that. That's not bad. 125.6 volts. That is actually the line voltage on the secondary, 125.6 line voltage. And what I want you to do now is think your way back to this circuit. This is a 6-pulse rectifier. The form factor should be 1.35 times E line. So if I have an E line of 126 volts, multiply that by 1.35, and it's I think you're going to find that it's around this number. This is the DC voltage. DC voltage across the load, 165.4 volts. Now, if you take this DC voltage and you divide it by the 60 ohms of the load, then this current ought to be the right current, 2.7 amps of DC current. So the 2.7 and the 165 DC volts, those are your load values. And to calculate the power that's being dissipated in the circuit, you simply multiply this current times the 165 volts. All right, and that's what's going to give you actually the load power. Now, we've looked at the, we see the line voltage, we see the load current, the load voltage, and we've taken a look at the hookup. Now let's look at the most interesting part of all. And I'm going to grab the scope, okay? Okay. Try and get a nice grip on the scope right away. Okay, here we go. That's not too bad right there. Now you see that little tiny riffly line at the top? That is actually the ripple voltage. Now the peak of this voltage we want to calculate carefully. We should be on 50 volts per division. 50 volts per division. So if you go 1, 2, 3, 1, 2, 3, looks to me like we're at 50, 100, 150. The peak should be about 170. In this case, probably 175 volts because we're a little higher than 120. So if the line voltage is 120, the peak voltage should be real close to 170 volts. And so that means that 170 volts minus just a little bit, see the ripple voltage goes from 170 and it goes down. And if you calculate it out, the minimum voltage will actually be 86.6% of 86.6% of the peak voltage will be the minimum voltage. Now, what I want to do, and I'm going to see if I can do this without breaking anything, is I want to unplug one of the diodes. Now look at that. There's 0. Now you can see 0, right? Now you can see 0 down there at the bottom. Now, what I'm going to do is I'm going to stop this, freeze it. There you can see it. See, you can see all the ripples except there's that one that we pulled out, and so it drops down to 0 now. So what happens if we pull one of the diodes? If one of the diodes burns out, well, our voltage just goes down. And I'm kind of curious. Let's take a look at the actual voltmeter, and let's see what the voltage is down to. Okay, I'm going to move this over this way, and the voltage is down from 165 down to 137.5. So it makes quite a difference, doesn't it? And let's pull another one out and see what happens. Look at that, down to 82.4 volts. So it just goes lower and lower, right? So as you start incapacitating diodes, basically your load voltage goes lower and lower. Now I'm going to plug those bad boys back in, and you're going to see that we're back up to the 165.5 volts again. And you see that the ripple voltage has gotten real small. It's just that little riffly line on top. Okay, so very, very interesting to look at the scope images on this. And set that over there. Perfect. All right, so with either one of these, now we've done two, right? With either the half wave or the full wave, the power is just the line voltage, or sorry, the load voltage times the load current equals the power. So for this one, it's simply 165.4 volts times 2.7 amps. In the half wave that we did just previously, I think there we had about 145 volts, and we had, I think it was 2.36 amps or 2.4 amps maybe. And so the load power, very easy to calculate in the three-phase rectifiers. Not like the single phase rectifiers where, yeah, it's a little, it's not quite as easy there. All right, so that should give you a reasonably good idea of what the values and the numbers look like in this three-phase rectifier circuit. And these diodes are the diodes these are the same diodes that are shown in I'm giving you a little, I'm giving you one clip that's a little bit of a lab overview for this lab, and it should have the data sheet for these for these rectifier diodes should be included in that clip. So you can refer to those to get the actual current and voltage of these particular diodes. All right, that's good for this one, and let's carry on to the next thing. All right.